Okay, another day, another Leetcode. You thought I forgot about you guys, eh? No, I did not. I did not forget about you guys. All right, so remove duplicates from a sorted list. Let us see what it's about. Okay, remove duplicates from a sorted list. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Okay. So basically we have 112 linked list sorted. The thing with linked lists is all you really need to know if it's a singly linked list or a doubly linked list, first of all. And the way this diagram shows you it's singly linked list because the arrows only go one way. Doubly linked list, you can go the other way. So there would be a head and a tail node that you would have to keep track of. Energy drink. Get the brain functioning, you know what I'm saying? Example 2, 1, 1, 2, 3, 3. The number of nodes in the list could be 0 to 300. Node values could be negative 100. Okay. So this right here doesn't actually matter. The negative 100 to 100. Because we already know from this it's sorted. Return the linked list sorted. And then given the head of a sorted linked list. So all we have to do is take out the duplicates now. The list is guaranteed to be sorted in ascending order. Okay, so as usual, let's delete this shit off the side. Okay. So now I want to locate the head node. Okay, so they give us the head node. So I'm going to call this temp or ptr pointer 1 equals head. So my objective here, and let's get the whiteboard out. Free online whiteboard. So these are linked lists. So I go 1, boom. I'm doing this on a trackpad, so fucking bear with me. I don't want to hear no one saying, "Oh my god, Kane. Oh my gosh, bro, I can't fucking keep track of the whiteboard." Like, yo, chill out, alright? So this is a node 1, 2, 3, 4, 5, 6. So I got 6 nodes. So let's do a realistic example. This would be 1. Value 1, value 1, 2, 2, 3. So it's guaranteed to be sorted in ascending order, but there would be duplicates. So what I'm trying to do is I created a pointer. They give you the head node already as given. So I'm going to say this is equal to a pointer, because the head node is something we always have to come back to, because when we want to return a sorted linked list, we can't just return the list itself. We have to return the head. In a singly linked list, this is the most important address, because this is what links you to all this. You know what I'm saying? So I created an extra pointer. So ptr1 equals head, pointer 1. The other thing I want to do is I want to keep track of whether there's a duplicate. So I'm going to create a second pointer, ptr2. Okay. So PTR2 is going to be equal to PTR1. So if PTR2 is equal to PTR1, actually no, I'm not going to make it equal. I'm going to start it on the next one. So PTR2 is equal to PTR1 dot next. Forgive me, it's messy. So PTR2 is equal to PTR1 dot next. So PTR1 dot next, in order for me to figure out the address, I need to have the head node. So the head node is PTR1, pointer 1. I call PTR. PTR2 is going to be the next element. So in order to do that, I need to have the address of the head, because the head dictates where the rest of the links go, right? So now that I have the head node and I label it PTR1, I want to see if it's a duplicate. I want to see if there's duplicates of PTR1, and if there are, remove them, right? So what I'm going to do is, I've already named this as the next. So now we're on here. We have one pointer on the first node, one pointer on the second node. If PTR1's value is equal to PTR2's value, which is PTR1.next, then I want to go to I want to skip this node. I want to take this link and skip it, right? Because this already has the same value as the original node. So PTR1 is equal to if PTR1's value is equal to PTR2's value, PTR2 is going to be equal to PTR2.next. If PTR2's value is equal to PTR1's value again, so let me remove all these unnecessary arrows. And let's take this. Let's erase that. Let's erase this. Let's get my pen back. Okay, so this and this are equal, right? So now I want to be able to remove this node because it's a duplicate. But if we look over to the right, the next one's a duplicate. So we're just going to follow the steps now. So it was here. Now PTR2 is going to be here. Then we run it again. If PTR2 is equal to PTR1, then we can skip it once again. We go to the next node. So now that if PTR2 is not equal to PTR1, so now we can check if PTR2, so PTR2 is here, because we confirmed the first node was equal to this, so we went to the next. We confirmed this node is equal to this, so we went to the next. This node, is it equal to this? No. So what we're going to do is make head, which is PTR1 dot next equal to PTR2. So now instead of all these links disappear, because we're taking this dot next and we're making it this. So we're making it this PTR2 that's not a duplicate. So PTR1.next is now this. So PTR1.next is now PTR2. And then, what's it called? PTR1 is now equal to PTR2. So I moved the original pointer. So I move this here now. And then I make PTR2 equal to PTR2 dot next. And then we repeat the process. So PTR2 is equal to PTR2 dot next. So here. So now is PTR2 equal to PTR1? Yes. So we skip it. And so we skip it. Now is PTR2. So PTR2 is now here. Let me erase this. So now basically it's saying, is PTR2 equal to PTR1? No. So now we do the same thing. PTR2 now PTR1 is now PTR1.next is now equal to PTR2 dot n. So PTR1.2 is equal to PTR1.next is now equal to PTR2. So we skip this link. And then PTR2 is equal to PTR2.next. So that's going to be null. And then PTR1 is going to be PTR2. So that way we rearrange the next pointer, we move the original pointer here. Then when the loop runs again, it's going to be, okay, pointer1.next is null. So now we break out of that loop. And then we return the original head node. See, we use these two pointers, pointer1 and pointer2, to give us and sort and remove all these duplicates. Then we return the original head node, because this is the address that links to this new sorted list. So now let's try and put it into practice here. PTR1 is the head node. PTR2 is equal to PTR1.next. While PTR1.next is not null. I don't know why these indents are weird. Okay, because Python, the indents matter in order for it to execute properly. So if oh yeah, there's also going to be the case where you could have no duplicates. And in that case, you just return. But the logic stays the same. So if PTR2, because we want the while loop to do the same thing all the time, unless there's an instance where there's a duplicate. So if 2 is not equal to, oh wait, so we have to look here as well. Each node has a value, so that's what's contained, and the next pointer. So basically, pointer 1 is head, pointer 1 dot next is pointer 2, if pointer 2 dot value is not equal to pointer 1 dot value pointer 1 dot next is equal to pointer 2. So if it's not equal to, so if we finally get pointer 2 is 2, we have to shift this to the new node. So pointer 1 dot next equals pointer 2, and then pointer So first we take the original node, shift it to the new location, the next value. Then we make the original node value for pointer 1, the new node 2. So pointer 1 equals pointer 2. And then pointer 2 is equal to pointer 1 dot next. Otherwise, if it is equal to the value pointer 1, so let's say pointer 1 and then pointer 2 is also 1, pointer 2, which is pointer 1 dot next, is equal to pointer 2 dot next. So just go to the next one. And it's going to keep doing that. Pointer 2 dot val checks if it's not equal to pointer 1 dot val, then it goes to all this. Otherwise, just keep going to the next node until your pointer 1 equals until your pointer 1 dot next equals none, which means we're at the end of the list. So once we're at the end of the list, we return the head node. So let's run that. Feature2.next equals null. And if, let's say, PTR1 goes to null. So let's say we have a whole array of duplicates. It's going to go next, 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 next until it hits null. put one if ptr2 equals null or none. Or I put or ptr2.next if ptr2.next equals none, right? Let's say if we have full array duplicates, so it's like 3, 3, 3, 3, 3. I want to go 1, 2, 3, 4, 5. I want to take my ptr ptr1.next equals none. Break. And then it'll break out of the while loop and then return the head node. Because it's going to keep going, right, until it hits the last node. So let's try that. Why? ptr2.next equals none if invalid syntax equals, oh, because I'm using equals, I'm not using, because that's an assignment character. Let's try that. Okay, so case 2 works. So you see how we have 1, 2, 3, 3, 1, 2, 3. Where does it fail? I'm just curious. Why does it fail? Okay, so 1, expected 1, 2. Why not do this? Boom. So instead of ptr2.next, because by looking at the test case, we can kind of adjust our strategy. So the test cases are really important, and I really want to stress this. Your test case determines the robustness of your solution. So let's say you're creating an addition function, right? And you say 1 plus 1 is 2, okay? And you add 2 numbers, right? You also want to make sure you're correctly adding like negative numbers or negative to positive numbers, right? Or you want to make sure that all these little edge cases are added to your tests so that when you have a function that says let's add 2 numbers, it always spits out the correct answer. So what's happening here is the first case was an edge case, right? So let's start with the second case that we knew would work. 1, 1, 2, 3, 3, right? Because there's gonna be duplicates. It's gonna pretty much eliminate all these duplicates before it gets to the end. So there's never gonna be a test case where ptr2 is equal to none. ptr2.next, right? So in the first case, let's look at why it failed. It said the output was 1 and it expected 1, 2, right? So the reason why it outputted at 1 and not 1, 2 was because I wrote it here as ptr2.next equals none. So it got to here and it's just like, all right, it's next equals none, break out of the loop. So it didn't do any of this valuable stuff here. We want it to do that. So what I'm going to do is I took out this next, and if ptr2 is equal to none, because it always goes to ptr2 equals ptr2.next, it just keeps shifting the pointer, then I just break out of the loop because I know that I'm at the end of the loop and I've made, if I'm at the end of the loop, there's no more duplicates, and we're at the end of the list. So let's just take whatever the next pointer is from the first PTR1 and just make it none, because that PTR2 is equal to none. So we're done. Break. And then just return the head. So let's submit this. Runtime error. Runtime error. What? Let's go back to the description. List is guaranteed. Number of nodes in the list can range from 0. Okay, so if 0, if head.next equals none, return head. Let's try that. That'll fix things. Cool. I'm just trying to see if there's an edge case. Why is it not attribute none type has no attribute next? If head.next. What am I supposed to return? Return the linked list. So we're not returning an array. We're returning a linked list. So return head. Okay, if head.next, first if head equals none, return none. Because it could be 0. See? It's all these bunches of edge cases. So it did end up, I said at the very beginning, and I just want to kind of backtrack. I had the right idea, but I was wrong about my premise, my thought process in the beginning. So I want to go back and look at this. I want to show you guys this. Number of nodes in the list is in the range 0 to 300. There could be 0 nodes. So if your head node, the beginning node, is a none value, which means it's an empty list, you have to return none. If head.next is none, then you just return the head node. It's just one item. Right? So these are the constraints. You always have to make sure that your solution aligns with these constraints. But as you can see, if you understand your test case and if you understand your constraints, you can actually use them as clues to solve your problem. Because then you just work with your compiler and figure out, okay, there's a none type. So obviously, I'm hitting none before I want to hit none. Or I'm hitting none and that's not what I expected. So why am I hitting none? And then you kind of backtrack. Okay, you think backwards. Okay, if I don't want to hit none and I'm looking at the next variable, let's just look at the variable, not the next. So if the next is none, it makes sense that if the variable is none, then it makes sense that the variable next is also none. So we just look at 1 and then you backtrack. So now that I covered these two edge cases and I covered my edge cases here for pointer 2, because we're not just looking at one pointer, we're looking at 2 pointers. We only have to pass through this loop 1 time. So it's an O of n time. And in best case, if it hits any of these, it's O of 1 time. Right? So best case, it's O of 1 time. if you do make it to a list that's longer than one node or 0 nodes, then you're going to have O of n time, because you're only going to do one pass. You're only going to do one pass with pointer 2. So take a look at it this way. This is pointer 1, this is pointer 2. Pointer 2 is just going and doing its thing. Only when we find duplicates is when we move pointer 1. But if you look at this, you're not redoing it. So you only do one pass of this list. So therefore your time complexity is going to be O of n. Right? For space complexity, it's going to be O of 1, because you're just storing the 2 pointers. Right? You're not storing a growing list. You're just storing 2 pointers that change as the values change. So I just want to run it again to show you that it works. And boom, it beats 86.7% of the rest of the people that tried to solve this problem. So they probably use some other methods. There's obviously other ways, but this is the most efficient way that I could think of. And this is the most intuitive way that I could think of, because it just makes sense. I don't want to keep passing through the same array over and over. Like, another way to do it is you could use some sort of a set or something like that and reconstruct it, or I don't know. It sounds like a lot of work to me, but this is the best way that I could think of. So if you liked the video, please give it a thumbs up. Subscribe to the channel, where I will be producing more of these types of videos, and feel free to leave your comments in the comment section below. Tell me your feedback, if it was good, bad, what you'd like me to change, and I'd be eager to address those concerns. But yeah, another day, another Leetcode. We solved it. Knologist out.